All right, guys, we're going to be trying something new here today, so you'll have to learn and grow with me. But it says the learner will understand how to predict using linear models. So remember, in the last lesson, we talked about positive correlation, negative correlation, and no correlation, things like that. However, this time, what we're going to do is we're going to use the calculator to help us actually use the positive or negative correlation to predict things. All right, it says the line that most closely follows a trend of data is called best fitting line. The process of finding the best fitting line to model a set of the data is called linear regression. So that's something we're going to have to remember for this calculator. So make sure you have your TI-8384 calculator with you. It says you can perform linear regression using technology. Using a line or its equations to approximate a value between two known values is called linear interpolation. Okay? So before we go any further, what you need to do is pause this, and you need to hit the stat key and then enter, because it should say stat edit. So stat enter, and you see these list 1, list 2. If you highlight the L1 and press clear, it'll clear the list if there's something there. Okay? And then what you need to do after that is you need to come over here and you're going to watch. So after that, just after you've paused it and entered these numbers in list 1 and these numbers in list 2, then go ahead and press play and keep watching. So we're going to watch this video here.
Hey there, we're back. This time we're going to go through how to do linear regression with the calculator, and moreover, get the calculator to graph it for you. Wouldn't that be great? Alright, so let's remember where we were. We have had stat edit. We have the data in that was from the notes. Or if you don't know those notes, it's okay. It's just a problem over here about smokeless tobacco. And now we're going to try to find the linear model. Now let's first go back and look at our y equals. We don't want this equation.
Now you guys, don't worry about the other worksheet. Don't worry about everything. What you need to focus on is learning how to just get the linear regression, okay?
So let me clear that out. And let me go up and press enter. And that way when I move away, it's still dark. And then I'm going to press zoom 9, and it'll make an automatic window that fits the scatter plot. Great. Now, stat edit is where you enter the data. Over here is the calculate menu for statistics. So you want to move to the right, and there's a whole bunch of stuff in here. Now in chapters 2 and 3, we're only going to work with number 4, linear regression.
And that's the only thing we're going to be working with right now is linear regression. Don't worry about what she says about the others.
5 you're going to work with in chapter 6 and 7, and number 9, you can't see it right now, but you work with that one right there. 0, excuse me. In some calculators I believe it's 9, in some calculators it's 0. It's exponential regression, which you work with in chapters 4 and 5. So we want number 4, linear regression. So let me go to that. Or I could just press the number 4, or you can go up to it and make it dark and press enter. There you go. It doesn't matter that it's got all these numbers on there. That's not going to hurt anything. So it's saying linear regression ax plus b. Should look a lot like mx plus b, right? Because it's the equation of the line. Now if I just press enter right away, it finds the equation of a line. The equation of the line through these points is y equals negative 0.554x plus 13.432, yada, yada, yada. Now it has all these decimal places. I like to keep them all because if I keep them, that keeps a lot of accuracy for me. But if I go back and look at my equation...
Don't worry about keeping all of the points, but it is helpful to watch and learn.
I don't feel like going to go type all of that. That's annoying. So let me show you how to do it. Stat, calc, number 4. But instead of pressing enter right away, let's do a little funky stuff. Let's press the variables button. VARS, that stands for variables. It's right here below your left arrow. And you're going to move to the right to the Y variables menu, because we want a Y variable. You'd always choose number 1, functions. Press 1 or press enter. Either way will work because it's already dark. So I'll press enter. then choose whichever one you wanted. Let's say I want to store this as y1, so I'm just going to press enter because y1 is already dark. So it's saying I will run the linear regression for you, and I will store it in y1 for you. So now let me press enter. And it did it. It looks like nothing happened, right? It's the same thing as before. But something did happen. Press y equals. You can see that it put the equation in there for you. Isn't that great?
Okay, so if you don't remember now how to be able to get this equation by going to stat, calc, linear regression after you've entered the data, then watch this again, okay? But we're going to move on to our problems now. Okay, so extrapolation. Using a line or its equation to approximate a value outside the range known values is called linear extrapolation. So when you're trying to make predictions, things like that, you're using linear extrapolation. You need to know this in case there's word problems or something that deals with this, okay? Accuracy. Don't worry about it. It just says what accuracy is. It says, as example 2 illustrates, the farther removed an x value is from the known x values, the less confidence. So if I'm trying to make a prediction about 2016 using linear regression, that's going to be more accurate than if I'm trying to make a prediction using 2036. The further away you get, there's more chance for error. That's what that's saying, okay? All right, so it says, find the equation of the line that models the data. So if you did that, you should have gotten y equals negative 0.554x plus 13.432. We're just rounding. So then it says predict when x is 22. So you would say y equals negative 0.554 times 22 plus 13.432. If you put that in, you would get y equals 1.244. Okay, so there we go. Now we know on our calculator how we can use this to do the linear regression. Again, if you're not getting it, watch it again. You should know how to do this when you enter the room. Okay? All right, so it says the table shows the median floor area of a new single-family house, or new single-family houses in the United States during the period of 1995 to 1999. So these are the years, these are the square feet. It says find an equation that models the floor area in square feet of a new single-family house as a function of the number of years since 1995. So this is really like 0, 1, 2, 3, and 4. Okay? So what you need to do is enter these into your L1, enter these into your list 2. So remember, you hit the stat edit key. So go ahead and pause the video and enter those in, okay? Then find the equation. Remember, you go to stat, calc, linear regression. All right, so if you ran the linear regression, we round to one decimal, you should have gotten y equals 26.6x plus 1,921.4. So it says predict the median floor area of a new single-family house in 2000 and in 2001. So here's the thing. So for part B here, you're going to do y equals 26.6 times, now 5 plus 1,921.4. And calculate that in your calculator. And then for the second part, you're going to do y equals 26.6 times 6 plus 1,921.4. See, the reason we're using 5 and 6, because remember, the x's are the years since 1995. Okay? So just plug those in, hit enter. You should be able to get a good answer. Okay? Now, for part C, it says, which of the predictions from part B would you expect to be more accurate? Explain your reasoning. Okay, so you remember, this is what I was talking about. So which one is further away from 1995? 2000 or 2001? Well, 2000 is further away, so it's less accurate. So we would say 2000 is more accurate because closer to the initial year. Okay? Let's take a look at some others. Alright, zero of a function. A zero of a function y equals f of x is an x value for which f of x equals 0. So it's the y-intercept. Okay? Because y equals 0 along the x-intercept. Because y equals 0 along the x-axis of the coordinate plane, a zero function is an x-intercept of the function's graph. So it just means set the function equal to 0. So let's take a look here. It says the number of y in thousands of the jet boats purchased in U.S. can be modeled by the function y equals negative 1.23x plus 14, where x is the number of years since 1995. Find the zero of the function. Explain what the zero means in this situation. Okay, so you say 0 equals negative 1.23x plus 14. Subtract the 14. Equals negative 1.23x. Divide by negative 1.23. You get x equals 11.38. Okay? So now we have to say what that means. Okay, so this means in 1995, what are we talking about? Jet boats. The average jet boat cost $11,382.11. How'd I get that? Well, I didn't round yet because I went back to the calculator. And how'd I get the 11,000? Well, see how this says in thousands of dollars? That means you need to take this number times 1,000. Okay? All right, we'll see you guys in class.